All right, in example 4e, our exponential equation is 4 raised to the x squared power is equal to 2 to the x, okay? Remember, when you get the final exam, you could have anything from all semester on here, okay? So if you see an equation, you need to know what you're working with, okay? Is this quadratic? Okay, well, yeah, there's an x squared, but remember, you have the variable x in the power. That makes this exponential. Okay, so you always need to identify what kind of equation you're working with first so you know the correct procedure to perform. Okay, again, the variables in the power, that makes this exponential. Okay, we need to try to get the bases the same on both sides. When you look at this, the base on the left side, what you're raising to the power, you have base 4. But on the right, you have base 2. Okay, you can't equate the exponents until the bases are the same. Okay, so remember what we're going to do. We need to change the bigger number into the smaller number. Okay, so we're going to go with base 2. We're going to try to make both sides base 2. Since the right side is already base 2, we're just going to leave it alone. Okay, on the left side, 4 is the same thing as 2 squared, okay? And I'm highlighting this in yellow. The yellow stuff is equal. 4 is the same thing as 2 squared, okay? 4, which is 2 squared, is raised to the x squared power, okay? So again, all I've done on the left side is rewrite 4 so that it is the same thing as 2 squared. Okay, so I still have 4 raised to the x squared power. Okay, now I've got base 2 on the left and base 2 on the right. Okay, now before I can equate the exponents, you need to simplify the exponents before going on. Okay, this is where the laws of exponents come in handy. Okay, so when you look at this on the left, you've got a power of 2 raised to a power. Okay, this is the situation where you multiply the exponents. Okay, so if you go back to the laws of exponents, okay, that is this situation right here. If you can see where my cursor is, if you have a power raised to a power, you multiply the exponents. Okay, so since we have a power raised to a power, we multiply the exponents. So we're going to keep the base of 2. We're going to multiply the exponents. 2 times x squared is 2x squared. Okay, that is going to be equal to 2 to the x. Okay, you have to simplify the exponents before going on. Okay, all right, now we have a power of 2 equal to a power of 2. The bases are the same. Now we can equate the exponents or the powers. So we can write down that this is equal to this. And now we can solve for x. All right, so now we have to solve this statement for x. Okay, we have 2x squared is equal to x. Okay, this is no longer exponential. Okay, it is no longer exponential. The x is not in the power. Okay, so you have to ask yourself, what kind of equation is this? Well, if I scan it, the highest power of x is 2. This is quadratic, okay? So your options for solving this, you can either factor or use the quadratic formula, okay? Regardless of which way you go, one side has to be 0 before you even start. So I'm going to go ahead and move the x over. So I'm going to subtract x from both sides, okay? This is going to tell me that 2x squared minus x is equal to 0. Okay, this one looks pretty straightforward to factor, so I'm going to solve by factoring, but again, you could use the quadratic formula with a being 2 and b being -1 and c being 0. Okay, all right, if I factor the non-zero side, okay, there is an x common to both pieces. We're going to take that out. That's going to leave us with 2x minus 1. Okay, and again, you can check yourself by multiplying this back out. You're going to get 2x squared minus x. Okay, all right, so that's what's equal to 0. Okay, we have factored. Okay, so now we need to take each factor, each of the things we're multiplying together, set it equal to 0, and solve. Okay, so we're going to get x equals 0 and 2x minus 1 is equal to 0. Okay, so I'll write these guys over here. Okay, so we're going to get x equals 0. That's going to be one solution. The other solution is going to come from 2x minus 1 is equal to 0. Okay, add 1 to both sides and then divide by 2. And so you're going to get another solution of x equals 1/2. Okay, so in this situation, we have two solutions. Okay, x can be 0, okay, or x can be 1/2. Okay, again, you can check yourself by plugging both of these into the original statement to see if you get a true statement. Okay, and that's it. Okay, that's how you do that one. All right, let's move on to part F. Okay, here, when you look at this, okay, again, imagine you're on the final exam and you see a problem like this. First thing you need to realize is this is an exponential equation. You're looking for x. It's an equation. What value of x is going to make this a true statement? X is in the power, so that means it's exponential. Okay, first thing you need to try is to make the bases the same on both sides. Okay, if I look at the left side, the base is 9. 9 is being raised to the power. On the right, 27 is being raised to the power. Okay, the bases are different. You need to try to make them the same. So always we change the bigger number over to the smaller number. Okay, so if you start trying to write 27 as a power of 9, 9 to the first power is 9. 9 squared is 81. Okay, so you can't write 27 as a power of 9. Okay, so what's going to happen here is you're going to have to change both numbers. Okay, 9 and 27 can be written as a power of 3. Okay, 9 is 3 squared and 27 is 3 cubed. Okay, 3 times 3 is 9. 3 times 3 times 3 is 27. Okay, so on the left side, 9 is the same thing as 3 squared. Okay, so the yellow stuff is equivalent. Okay, we need to take the 9 and raise it to the negative x plus 15 power. Okay, so I have 9 raised to the negative x plus 15 power. On the right, 27 is the same thing as 3 cubed. Okay, so the stuff in blue is equivalent. You need to take 27 and raise it to the x power. Okay, all right, so now we at least have the same base. Okay, remember, the bases are the same, so ultimately we're going to equate the exponents. But before we can do that, we have to simplify the exponents. Okay, so on the left, we have a power raised to a power. That's when you multiply the exponents. Okay, so we're going to have a base of 3. 2 has to be multiplied by this entire quantity, negative x plus 15. So you absolutely need parentheses here. Okay, you're having to distribute here. Okay, 2 times the entire quantity, negative x plus 15. Okay, you have to use parentheses there to distribute. Okay, on the right side, you also have a power raised to a power. Again, you're multiplying the exponents. So 3 times x is 3x. Okay, all right, so let me keep going. On the left, if I do the distribution, I'm going to get negative 2x plus 30 as my exponent. Okay, and then no changes to the right side. Okay, now I've got base 3 on both sides. The exponents are completely simplified. Okay, so since I have the same base, simplified exponents, I can go ahead and equate the exponents. Okay, so we're going to set negative 2x plus 30 equal to 3x, and we're going to solve for x. Okay, so this is a linear equation. The highest power of x is 1, so we just need to isolate x. Okay, so I'm going to put everything with an x on one side, all the numbers on the other side. I'm going to add 2x to both sides. That's going to tell me that 30 is equal to 5x, okay? And then if I want x, I just need to divide both sides by 5, and so I get x needs to be 6, okay? And that's it, okay? There's your answer, okay? Again, you can check yourself, okay? You should, okay? Like for example, if I go to the calculator and I type in 9 raised to the negative 6 plus 15 power. Let's see what we get. Okay, 9 raised to the negative 6 plus 15 power. Okay, we get this big number. Okay, does that equal 27 to the 6th power? Check it out. Yes, it does. Okay, so we know we have the correct answer.